Everyone says QLever is amazing. And then Windows users are like, cool, how do I run it without summoning demons? I'll show you the cleanest way to run QLever on Windows using Docker. Index a turtle file, start a SPARQL endpoint, and optionally launch the UI. Beginner mode, no pain, minimal crying. First, you need Docker Desktop. If you don't have it, pause, download it, and come back. Done? Great. Now, open your terminal and grab the latest QLever image. It's the engine that makes the magic happen. Create a folder like C, the Semantic Owl, QLever. Inside it, add two files, my_data.ttl and a tiny JSON settings file with this line. That's it. One folder, one dataset, one settings file. Simple. Here is where everyone fails. They don't subscribe to the channel. Kidding. The thing is that Docker doesn't speak Windows paths. If your folder is like this, Docker needs to hear it like this. Switch those slashes and everything clicks into place. Now comes the part that makes QLever fast. Indexing. Before going hands-on, let me explain in brief some stuff. Your TTL data file is just text, human readable, lovely, but QLever can't do fast on raw text. It needs to pre-build a database-style index first. Think of it like compiling. You pay the cost once, and after that, queries feel instant. During indexing, QLever basically does three big things. Turns long strings into compact IDs, so everything gets smaller and faster. Builds sorted structures, so it can jump to matching triples instead of searching everything. Writes everything to disk as reusable index files, so the server can load them later. So we're going to run one container, feed it the turtle file, and let it build the index inside our folder. All right, let's build the QLever index. Not the server, just the brain. Open PowerShell and follow along. We'll run one Docker container, feed it our turtle file, and let it create the index in our folder. When it's done, the container disappears, but the index files stay. Only QLever understands them, and later the server will turn them into a SPARQL endpoint. Let's break the command down, step by step. Docker run. This tells Docker, start a container for me. Think of it like borrowing a small temporary computer just to do one job. RM. When the container finishes its job, Docker quietly cleans it up for us. Nothing stays behind that we don't need. Nice and tidy, like putting the tools back after you're done. -v, blah blah. This is how we share a folder between your computer and the container. Your local QLever folder is shown to the container as /index, so anything the container writes there shows up on your machine too. Next, this says, start working from here. All reads and writes happen inside our shared folder. Name. We give the container a friendly name. It's not required, but it makes things easier to recognize if we ever need to check what's running. In it, this adds a tiny helper process inside the container. It makes sure everything starts and stops cleanly, especially for longer or heavier tasks like indexing. Entry point and image. Instead of starting QLever automatically, we ask the container to run a shell. That way, we can tell it exactly what command to execute. See, blah blah blah. Looks like it's trying to hack something, but really it just means run this command inside the container, then exit. It's one clear job, build the index. And when it's done, the container is finished. Inside that command, QLever reads your turtle file and feeds it in cleanly, compresses, sorts, and turns all the RDF data into a fast disk-based index, shows progress on screen, and saves a full log for later, so you can watch it work or check details afterward. All right, 3, 2, 1, enter. You'll see a lot of text flying by. That's normal. That's QLever doing real work. And if you look at your folder, you'll see it slowly filling up with new files. Index build completed. That's your confirmation. The hard part is done. At this point, we don't have a server yet. We have something better, a fully built QLever index. Now we're going to use that index to start the actual server. We're using Docker run again, but this time we're not building anything. We're serving. We're telling Docker, here's the index, keep it running. Let me query it. RM. When we stop the server later, Docker cleans everything up nicely. No forgotten containers, no junk left behind. D. This runs the server in the background. Your terminal stays free, and the server keeps running quietly. Next, we mount the same folder again, the one with the index we just built. This is how the server sees and uses those index files. W-index. The server starts working inside that folder, so it immediately finds the index without us pointing at paths all over the place. Next, we give the server container a friendly name. Makes it easy to stop, restart, or check later. 7001, 7001. This is the bridge between Docker and your machine. Port 7001 inside the container becomes port 7001 on Windows. Now comes the actual server startup. Type the command once and follow along. Here's what we're configuring. First, QLever starts its server and loads the index we just built. That index is the brain of the system. Without it, nothing can be queried. We tell it to use 8 worker threads, so it can answer multiple queries faster in parallel. Next, we give it memory limits, about 5 gigabytes for query processing, 2 for caching, and 1 for execution work. These are safe, reasonable defaults, not magic numbers. You can increase or decrease them depending on your RAM and dataset size. We also ask QLever to keep the last 200 query results in memory, which makes repeated or similar queries much faster. Every 30 seconds, the server updates its internal statistics, so performance stays predictable and visible. There's no authentication here. This is a local, open setup meant for learning and development. Finally, the server is started in the background, and all output is written to a log file, so it keeps running even if you close the terminal. And that's it. If everything went well, your QLever server is now live at localhost 7001. And yes, all these settings are just starting points. Once you're comfortable, you can tune them to match your data, your machine, and your use case. If you check Docker Desktop, you'll see the container running and waiting for queries. Now, let's quickly make sure everything works. Open Postman and create a new request. Set it to post and point it to localhost 7001. Add 2 headers, so QLever knows what's going on. In the body, choose raw to text and paste a simple query like this. Send. If you see a JSON response with triples, that's it. Your QLever SPARQL endpoint is alive and working. At this point, we already have a fully working Triplestore. You can stop here and use it via Postman, scripts, or anything else. But if you want a nice web interface for writing queries and exploring results, QLever also provides a UI. And setting it up is just a little extra effort. The UI runs in its own Docker container and connects to the server we already started. First, the UI needs a small database file to store users and saved queries. Instead of creating one manually, we simply copy a ready-made one from the image. These 3 commands do exactly that. Briefly create a temporary UI container. Copy the default SQLite database file to your local folder. Immediately delete the temporary container. Nothing keeps running. We just borrow the file and move on. Next, we launch the actual UI container. Here's what happens with this command behind the scenes. The UI runs quietly in the background. Your folder is shared, so saved queries and settings are stored locally. The UI knows where to find the database. Port 8176 on your Windows machine points to the UI inside the container. The container has a friendly name for easy management. Also, we need a super user to log in. Follow the prompts to set a username, optional email, and password. These will be your credentials to log into the UI and connect it to the server. At this moment, if you're still here, congratulations! We now have 2 containers running, backend at port 7001, frontend at port 8176. One crunches all the data, the other just shows off like it knows everything. Now comes the slightly less exciting but necessary part, telling the UI where its brain is. Open your browser at localhost 8176. Right now, it's just a pretty face with no brain attached. We still need to connect it to the backend before it can do anything useful. Click Resources, QLever UI Admin, Login, entering the superuser credentials you created earlier. Find and click the Add in Backends. Put a name, something clever, like the Semantic Owl. Don't judge. Make the sort key something above 0. In base URL, fill in the localhost 7001. Click Save. I love this screen. Go back to the home page, and voila! Your backend appears in the drop-down menu. Now you can finally write SPARQL queries and pretend you know what you're doing while QLever does all the heavy lifting. And that's it. A real Triplestore, a real UI, and zero demons summoned. You can stop the video now or start querying.